Friends, today we are going to learn about science fifth chapter inside the atom. So today we will continue the lesson inside the atom part second. The first one we will see about the Bohr stable orbit atomic model 1913. In the year 1913, Danish scientist Niels Bohr explained the stability of atom by putting forth stable orbit atomic model. So the important postulates of Bohr atomic model are as follow. So Bohr's concluded some points. They are follow. First one, the electron revolving around the atomic nucleus lie in the concentric circular orbits at a certain distance from the nucleus. So now here, which means orbit or circle have a same center. Then second, energy of an electron is constant while it is in a particular orbit. So second, energy of an electron is constant while it is in a particular orbit, means energy of electron is same, it does not change. Third one, when an electron jump from an inner orbit to an outer orbit, it absorbs energy equal to the difference of its energy level, and when it jump from an outer orbit to inner orbit, it emits energy equal to the difference of its energy level. So I put this picture for your reference. Green circle, this is our electron, and pink circle is a nucleus. So in orbit, some electron jumps from inner orbit to outer orbit and absorb energy, or some electron jump from outer orbit to inner orbit, it emits energy equal to the difference of its energy level. Then some more atomic models were put for after Bohr's atomic model. Atomic structure was studied at the depth with the advent of new branch of science called quantum mechanism. So atomic structure was studied at the depth with the advent of new branch of science is called a quantum mechanism. With all those, some well accepted fundamental principle of atomic structure are as follow. The atomic structure: an atom is formed from the nucleus and extranuclear part. This contains three types of subatomic particles. So atomic structure contains three types of subatomic particle. First one, nucleus. Second, extranuclear part. Or third one, electron. First one, nucleus. The atomic nucleus is a positively charged. Almost the entire mass of an atom is concentrated in the nucleus. So first one, nucleus is a positively charged. Almost the entire mass of the atom is concentrated in the nucleus. The nucleus contains two types of subatomic particles together called nucleons. Means proton and neutron are the two types of nucleons. The nucleus include two types of subatomic particle. First one, proton, and second, neutron. So you see this diagram, the red and blue circle, you can see they together form nucleons. Now the coloration just for the reference. Now again look at the diagram. The red circle, I have named that neutron, and the blue circle I have named that proton. So once again I repeat, the coloration is for reference. Then next point, proton. The proton is a positively charged subatomic particle in the atomic nucleus. Proton is a positively charged subatomic particle. The positive charge on the nucleus is due to the proton in it. A proton is represented by the symbol of P, small p. Each proton carries a positive charge of plus 1e. When total positive charge on the nucleus is expressed in the unit E, its magnitude is equal to the number of proton in the nucleus. So the number of proton in the nucleus of an atom is the atomic number of that element and is denoted by the Z. Mass of one proton is approximately 1 U. 1 U means 1 Dalton. So you can understand the number of proton in the nucleus of an atom is the atomic number. Our atomic number is denoted by Z. So atomic number is equal to number of proton. Then next point, neutron. Neutron is an electrically neutral subatomic particle and is denoted by the symbol small n. So neutron is a electrically neutral, means without any charge. The number of neutron in the nucleus is denoted by the symbol capital N. Atomic nuclei of all the elements except hydrogen with atomic mass 1 U contains neutrons, and the mass of neutron is approximately 1 U, which is almost equal to that of proton. Then next point, extranuclear part. The extranuclear part in the atomic structure includes electron revolving around the nucleus and the empty space in between the nucleus and electron. So extranuclear part. Now see this diagram, you can see the empty space between nucleus and electron, that is nothing but a extranuclear part. The empty space between nucleus and electron, that is nothing but a extranuclear part. So next point, electron. Electron is a negatively charged subatomic particle and is denoted by the symbol E. Electron carries 1 unit of negative charge. Mass of an electron is 1800 times less than that of hydrogen atom. Therefore, the mass of an electron can be treated as a negligible. Means the mass is very small. So it is a negligible. Then see the circle you in a diagram. Circle in a diagram is a 3-dimensional. We do not use orbit, we can say shell. Means electron in the extranuclear part revolve in the discrete orbit around the nucleus. The orbit being 3-dimensional in nature, a term shell is used instead of term orbit. So we do not use orbit, we can say shell. The energy of an electron is determined by the shell in which it is present. Then the number of electron in the extranuclear part is equal to the number of proton in the nucleus. So you already know the atomic number is denoted by the Z. So atomic number is equal to number of proton. Number of proton is equal to number of electron. Therefore the electrically charged are balanced and the atom is electrically neutral. Then carbon atom. This diagram include all these things. We will begin from nucleus. Now the nucleus contain neutron and proton. Now the red circle you can see neutron, and blue circle with plus sign is a proton because they have a positive charge. Now we can see two shell in one shell. We can see green circle with negative charge. Those are nothing but electron because they have a negative charge particle. Even see the empty space, this is nothing but the extranuclear part. So we can study about the atomic number is denoted by Z, or is equal to number of proton or number of electron. The mass of an electron being negligible, therefore the mass of an atom is mainly due to the proton and neutron in its nucleus. So mass is dependent on the proton and neutron in its nucleus. The total number of proton and neutron in the atom is the atomic mass number of that element. So what is the atomic mass number? The total number of proton and neutron in that atom is the atomic mass number, and atomic mass number is denoted by symbol capital A. So the convention to denote atomic symbol, atomic number and mass number are together in shown in as follow. So atomic number denoted by capital Z is equal to number of proton or number of electron. Then we have studied about atomic mass number is denoted by capital A. Atomic mass number is equal to total number of proton and neutron. Then symbol A or Z, for example the conventional symbol carbon, the atomic number or atomic mass. So atomic mass number of carbon is 12 and atomic number is 6, means that the atomic number, that is the proton number of carbon, is 6 and mass number of carbon is 12. From this it is also learned that the nucleus of carbon contain 12 minus 6, that is 6 neutrons. So in this point part second we have studied about the structure of atomic structure. It include nucleus, extranuclear part, or third one electron. So nucleus includes proton and neutron. Proton is a positively charged particle, neutron is a without any charge, means neutral, and third one electron is a negatively charged particle.